Here we have two linear maps where obviously the origin is a fixed point. And the question is the origin a stable fixed point, an unstable fixed point, or perhaps even a saddle point? So pause the video to do these calculations. Obviously, what we need to do here is calculate the eigenvalues. So let's start with question A. So we have a look at the determinant. So 4 minus lambda 30, 1, 3 minus lambda, that determinant should be equal to 0. So just some straightforward algebra. 4 minus lambda, 3 minus lambda, minus 30 equal to 0. So this gives us 12 minus 7 lambda plus lambda squared minus 30 equal to 0. Moving on, lambda squared minus 7 lambda and then minus 18 equal to 0. So this is a nice quadratic equation. We know since kindergarten how to solve this. So this gives us minus the b coefficient, so that's 7, plus or minus square root of 7 squared, and then minus the product of the a and the c coefficients. So there is already a minus there, so that becomes a plus rather. So plus 4 times 18. Divided by 2 times the coefficient of lambda squared, so that's 2. Now this then becomes 7 plus or minus, and this is 121 under the square root, so that's 11 squared, divided by 2, which is either 18 divided by 2, giving us 9, or 7 minus 11, so that's minus 4 divided by 2, giving us minus 2. So these are the all-important eigenvalues of that matrix. And we can clearly see that they are all in magnitude bigger than 1, which means that this is an unstable fixed point, a source. Good. In case you haven't done, pause the video to do exactly the same thing, but now for the second example. So slightly different matrix this time, but otherwise it's exactly the same thing that's going on. So we have 1 minus lambda, half, 1/4, 3/4 minus lambda. So that's the determinant, and that should be equal to 0. So this gives us 1 minus lambda, 3/4 minus lambda, and then minus 1/8 should be equal to 0. 3/4, and then let's have a look at the lambda coefficients. So we have 1 and 3/4 with a minus sign both. So this will give us 4 plus 3 is 7 quarters. So minus 7/4 lambda plus lambda squared minus 1/8 equal to 0. So let's reorder the terms, and let's also multiply everything by 8. Then we get rid of these pesky denominators. So that gives us 8 times lambda squared minus 14 lambda. And then we have 2 times 3 is 6 minus 1. So that should be 5. So this is finally our quadratic equation. Calculating the solutions, this time we can use the reduced formula, the reduced quadratic formula, if the b coefficient is even. So we have minus half of the coefficient of lambda, so that's 7, plus or minus 7 squared. And then we have minus the product of the a and the c coefficients. So this gives us minus 40. And then we divide by the a coefficient in the reduced formula. So that's 7. Finally, this becomes 7 plus or minus 3 divided by 8. So that's either 10 divided by 8 or 4 divided by 8. So 5 over 4 or 1 over 2 if you want. But here the important conclusion is that we have one eigenvalue which in magnitude is bigger than 1 and one which in magnitude is smaller than 1, which means we have one attracting direction and one repelling direction. And that is, of course, the hallmark of a saddle point. So in this case, the origin is a saddle point.